Hi, my name is qiang and this is my fare analysis system built for Dynamic Ride Solutions Pit Lead. The program analyzes average total fares across Singapore's 5 planning regions, comparing peak and off-peak hours filtered by vehicle type. There were 5 deliverables for this scenario. First, the program allows the user to filter by vehicle type using a while-true loop with input validation. And second, it tabulates the average fare by region and time period without using the tabulate module, which is by building the table manually with string methods. And third, it automatically generates an insight summary after every table. Fourth, the analysis keeps running the loop until the user presses enter with no input. And fifth, as a value add, the program will run one final analysis after the user exits, identifying which region has the largest percentage difference between peak and off-peak fares. The most important function in the entire program is the isPeak function I created. I determined the peak hours for the program on bus-linked peak hours timing in Singapore, since scenario 1 did not give any specific peak hour timing. This function takes a date time string from the CSV and returns true if the trip happened during peak hours, or false if it was off-peak. The key design decision here was to avoid any external datetime library. Instead, I implemented a custom day of week formula to detect weekends and converted the time to total minutes, which in this case, let's say 7:30 AM will become 450 minutes instead, making the peak window check a simple numeric comparison. This function is called on every single record in both the main analysis and the value add analysis. So moving on to my program flowchart. So step 1 and 2 will run once at the start, reading all the records from the CSV and displaying the welcome message. Step 3 will then ask the user for a vehicle type, and this will be where the loop begins. And if the user enters a valid type, the program will move through, calculating averages, displaying the formatted table, and printing the insight summary before looping back to step 3 to ask again. And if the users enter an invalid vehicle type, it will reprompt the user to enter a valid one instead. And if the user enters a blank input instead, the loop will exit. And then step 4 and 5 will then run once, executing the value add analysis and then printing the goodbye message in the end. For the demonstration of my program, this is what the user sees when the program first runs. It displays a welcome banner, explains the peak hour definitions based on Singapore bus lane hours, lists the available vehicle types read directly from the data, and prompts the users to begin their analysis. Here will be the actual output when I enter comfort as the vehicle type. The table will show the average fares for each of the 5 planning regions, split by peak and off-peak hours. The insight summary is generated automatically as it identifies East as having the highest peak hour fare at $9.27 and North as the lowest at $8.88. It also notes that overall, off-peak fares are slightly higher than peak fares for comfort vehicles by 3 cents. For the value add, once the user exits, the program runs one final analysis across all vehicle types. It calculates the percentage differences between peak and off-peak average fares for each region. The region with the biggest gap is the most sensitive to demand changes, which in this case, that's the North region at 1.83%. And that's where the marketing director could focus promotions or adjust pricing to balance ridership between busy and quiet hours. On the other end, the West region at 0.08% shows very stable pricing, suggesting demand there is already well balanced. In summary, the program fully addresses all 5 deliverables, fitting by vehicle type, tabulating fares without any external module, generating insights automatically, running continuously until the user exits, and lastly providing a value add regional analysis. All of this was built using pure Python with no external libraries. Thank you.